In this video, we are going to talk about solving exponential equations. Okay, so an exponential equation is just an equation that has an exponential function in it. The first example that we are going to start off with is probably the simplest type. And that type is when we have the same base on either side. So here the base is 7. And also over here the base is 7. And so anytime you have that situation, that the equation looks exactly like this with the same base on either side, and there's nothing else being added or subtracted to either side, then the only way that this equation could be true is if the exponents are equal to each other. Okay. So in other words, if 7 to the 2x power is equal to 7 to the third power, well, the only way that that can happen is for 2x to be equal to 3. In other words, the exponent over here would have to be equal to the exponent over here. Okay, so again, it has to kind of look pretty much exactly like this. If it's anything else, then you're probably going to have to do something else to solve that. All right, so now we can solve for the x by dividing both sides by 2. And so we get x equals 3/2 here. And that's it on this one. So you can see that's pretty straightforward. All right, in the next example, you'll see that we don't have that situation that we were just talking about. Over here, we have 25 as the base. So we have 25 to the x plus 4 power equals 5 to the 4x power. And so the bases are not the same, so we can't really do it exactly like we did in the previous video. But the thing is that 25 is a whole number power, right, of 5. It's 5 squared. Okay. And so it's not quite as easy as the problem before, but it's just really one step away from, or a couple steps away from being that easy. So let's see how to do this. Okay. All right. So it is very easy for us to write this 25 as a power of 5. And that is very helpful, right? 25 we know is 5 squared. And I'm going to put that in parentheses, and that will still be to the x plus 4 power. So here I'm just rewriting this 25 as 5 squared. Okay. And you can see it's still not where I have exactly the same base on either side. But what I can do is use one of the properties of exponents, that if I have a base and a power raised to another power, I multiply the powers together. Okay, so that would be 5 to the 2 times x plus 4. All right, so I'm just using that power rule for exponents to rewrite this. Okay, and now you can see that I'm in the situation from the previous example where the base on either side is exactly the same. So we know, right, that the only way that that can occur is if the exponents are equal to each other. So that allows us to simplify this equation out to here, to an equation just involving these exponents. Okay. All right, and then we would just solve that like we normally would. Distribute that 2 through the parentheses. Get 2x plus 8 equals 4x. Then I'm going to get all the x's on one side by subtracting 2x from both sides. That's going to leave me with an 8 over on the left-hand side and a 2x over on the right side. And then I'm going to divide both sides by 2. 8 divided by 2 is 4, and 2x divided by 2 is x. So the solution here is 4. Okay. So again, this was not exactly like the first example where the bases were exactly the same, but because 25 was an easy to write as a power of 5, right, just 5 squared, then I was able to do that and make this into an equation where the bases were the same. Okay, in the next example, this example is different from the other ones. So the first two were fairly easy because we were able to, they either had the same base or that we could easily make them into having the same base. But in this one, that's just not going to happen, right? I can write 24 as a power of 2, but it's just going to be some decimal number. I don't know, what that is off the top of my head. Okay. All right. And so what we're going to do to solve this, right, is to use that property of logs, or the exponential form and the logarithmic form. So remember, it was logarithmic form was log base b of x equals y. Right, that was the logarithmic form. And the exponential form was b to the y equals x, right? We talked about that in some previous videos. If you didn't look at those videos, you need to go back and look at those in order to be able to understand this, right? So this is logarithmic form, this is exponential form. So the base of the log, right, is the base of the exponential form. What the log is equal to is the exponent, right? That goes in the exponent position, and it's equal to whatever is you're taking the log of, all right? So this is exponential form. And looking at our equation that we have to solve, right, this is in exponential form. This form over here, right? We want to solve for x, so what we're going to do is switch it over to the logarithmic form. All right, so now you might ask, well, what base should I use? Okay, and it actually doesn't really matter a whole lot theoretically, right? You might say, well, I should use base 2 here to do that. And you definitely need to do that if you're going to use this approach here. Okay, so to do that, I would do log base 2, right? Because the base of the exponential function is log base 2. And over here, the x, right? What was by itself on the equal side in the exponential form goes inside the log here. And then the exponent, right, goes by itself on the other side of the equal sign. And so you can see just by rearranging, right, into this format, then we've got the solution. We've solved it already, okay? All right, so we have solved it using log base 2. The only situation with this is if you're trying to get a decimal answer, right, you would have to use your calculator or something else. Well, in Desmos, it's no problem, right? In Desmos, I can just type that answer in as log base 2 of 24, okay? And I can get the answer there, so no issue with that. If you are only using your calculator though, right, there is an issue with that, okay? And the issue is that your calculator only has either base 10, which is log, right, the common log, or base e, right, which is the natural log. And so if you don't have access to Desmos and only your calculator, well then, and you want a decimal answer, well then you would have to do something else. So there's a couple things that you could do to do that, and so let's talk about how to do those. All right, so if you only have your calculator and you want a decimal answer, One thing you can do is you would, instead of using log base 2 and using this equation, just take the natural log or log base 10 of both sides. All right, if these two sides are equal, then take the log, right, and they're equal to each other as long as these are in the domain of the log function, which they both are in this case. All right, and then I can use the property of logs to bring this exponent down out in front, right? That's that third property of logs. The exponent can come down out in front. Oops, that's supposed to be just 2. Like so. Okay, and so now I want to get x by itself after I bring the x down, right? I want to get it by itself on this side of the equation. I can do that by dividing both sides by the natural log of 2. And then over on this side, those values are going to cancel out. And I'm left with x equals ln 24 over ln 2. Okay. And so now this is an expression that can be entered into your calculator to get a decimal value. All right, and you can see I get exactly the same value here as I did here. Okay, so you could do it that way, right? If you only have your calculator and you want a decimal answer. There is one other thing that I will mention, and that's called the change of base formula. You can change the base, right, of any logarithmic expression to any other base through what's called the change of base formula. The change of base formula says that the log base b of x is equal to the log base a of x over the log base a of b. So you can see on the left side of the change of base formula, we have our logs are base b. And on the right side, they are base a, okay? So that's why it's called the change of base formula. You can change from one base to another. Okay, and then over here on the top, on the numerator, the change of base formula, it's log base a of x, which is the same x as over here. And then you divide by log base a of the bottom part, right? So just as an example, right, if I say I have log base 2 of 24, and I want to use my calculator, right, to get a decimal approximation for that, right, I can change this log base 2, which my calculator will not do, into one of the bases that my calculator will do, which is either base 10 or base e, okay, by following this formula, right? So it would be log, let's say I want to change to log base e, that would be log base e of x over log base e of 2, which is the base here. Oops, that should be 24 up there. Let me erase that. So log base 2 of 24 would be log base e of 24 divided by log base e of 2. Right, and remember log base e is just the ln, right? So this would be ln of 24 over ln 2. Okay. And so you can see that that's exactly the same answer we got by doing it this way. Okay. So again, basically I've shown you kind of 3 different ways, right, of working this problem out. Sometimes, you know, that can be confusing when you have multiple ways, but with this, I think it just pays to kind of understand each of the ways there, because sometimes this way to me is the easiest right here, solving an exponential equation like this, because all you have to do is remember this one, how to flip back and forth between exponential and logarithmic equations, right? And it's really easy to get it to that. You just flip it over and you're done. Boom, it's solved. Sometimes there's other steps that you have to do, and we'll go over examples for that. But the one downside to this method, right, is that if you're only using your calculator and you need a decimal answer, which for the Newton problems you're going to need, then you either have to use Desmos. If you only have your calculator, right, then you'll have to use one of these other methods over here. Okay. All right. All right, so here are the basic steps for solving the exponential equations, right? Number one is rewrite the exponential equation in the logarithmic form. And if there are two bases, use the third property of logarithms to bring the exponents down. We'll talk about an example of that. And then finally, solve for x. Okay, and I'm going to do some more examples. I will split those out into other videos.